Okay. So in this video, we're just going to look at two how to find area of a triangle, just based on trig. And again, I mean, one of them we actually saw before in honors geometry called Heron's formula, where you have all three sides and you can find its area. And the other one is based on just our normal 1/2 base times height formula, and you're just constructing, well, how else could you represent the height? And that's what I'll start with to show just kind of really quick proof. We know that area equals 1/2 base times height. We know that. And if I look at this triangle here, 11 clearly is the base, and the height of this triangle, at least in this perspective, is sitting over here. That's the height of that triangle. And if I think about, okay, well, that sort of creates this larger right triangle, who 17 is the hypotenuse of that larger highlighted triangle. And so if I think about in terms of the yellow triangle, I can come up with a ratio that the sine of this angle is equal to the opposite, which is h, divided by 17. So sine of 20 degrees is equal to h over 17, which means that if I multiply that height, h is equal to 17 sine of 20 degrees. Now look at where that comes into our original formula of 1/2 base times height. Well, here's what height was equal to. And so I can just certainly just insert that into that particular formula. And so now I have a formula that's based on not the height, but actually two sides and an included angle. And that's sort of the key, that you have to be, let me go ahead and finish that off. So area would equal 1/2 the base, 11, times 17 times sine of 20 degrees. Okay. And so that formula, just in a generic formula, or general formula, I should say, is 1/2 AB sine theta. And as long as theta is included in the two given sides. So you're really sitting in a SAS case where if you're given two sides and an angle that's included, you can use this formula. So if I were to stumble upon this problem without the proof next to it, and I say, okay, how do I solve this problem? So I would notice that I have my situation. It looks fine. I have two sides and an included angle. So I could say area is equal to 1/2 AB sine of theta. And it doesn't really matter what you call that angle. I just generically use theta when there's only one. So that's 1/2 17 times 11 times the sine of 20 degrees. And then again, so I just punch this in, to my calculator. 1/2 sine of 20 times 17 times 11. So I get an area that's equal to 31.979 if I go to 3 decimals. Okay. So nice handy little dandy formula. You didn't necessarily have to memorize it. If you just realized that you could have drawn a height over here and just use 1/2 base times height. Okay. The other one, Hero's formula, I'm actually not going to prove. I'm not sure I don't know how complicated the proof is, to be honest with you. So I'm going to take a look at that too. But it's based on the semi-perimeter. Excuse me. And a semi-perimeter is half of the perimeter of the triangle. So the first thing I'm going to do is I'm going to add up the whole perimeter of the triangle. So I'd do 15 plus 14 plus 10. So that's 29, 39? And then divide that by 2. So that's going to give me my semi-perimeter, or half the perimeter. So half of the perimeter is equal to the semi-perimeter. Okay, so 15 and 10 is 25, plus 14 is 39. So my semi-perimeter is 39 over 2, which is, 19.5. Okay. So now the formula to find this, it's based on Hero's formula, is the area is equal to the square root of the semi-perimeter times the semi-perimeter of side length 1 times the semi-perimeter of side length 2 times the semi-perimeter of side length 3. Okay, and so then that might, oops, I said 3 and I wrote the same thing. There we go. Okay, so then I would say, okay, my semi-perimeter is equal to 19.5, and then we take times, and then you just do 19.5 minus each of those. So minus the 15 would be a 4.5. Oops, I have my eraser on, sorry. And then minus the 14 would be a 5.5. And then minus the 10 would be a 9.5. So I know that it says exact area, and so I would want to leave in a square root, but at least to get an approximate area, I could do 19.5 times 4.5 times 5.5 times 9.5. And so as an approximation, 67.712. Now, when it says finding the exact area, that would be where you'd want to leave this perhaps as 39 over 2, and then just continue to use that as a fraction. So like I would say, oh, okay, my square root of 39 over 2, and really this is more of just a great exercise, not necessary, in this case, but that's my semi-perimeter. And then I could think, well, 15 is the same thing as 30 over 2, so 39 over 2 minus 30 over 2 would be 9 over 2. And then 10 is the same thing as 20 over 2. So 39 over 2 minus 20 over 2 would be 19 over 2. And then the same thing with the 14, which is 28 over 2. And so that gives you an 11 over 2. And I could say, like, well, look at 2, 4, 8, 16. So now the square root, there's a square root of 16 on the bottom, which becomes a 4. And then I know this is perfect square of 9 here. That's a 3. And everything else, everything else is pretty much relatively prime to each other. 11 is prime, 19 is prime, 39 has 3 times 13, but then they're both relatively prime. There's no other multiples. So then I could just leave it as a really big number of 39 times 19 times 11, and that would be 8,151. And then let's just double check to make sure, times 3 times root 8151, and then divide by 4, hoping it's the same number, 67.712. So if you like that challenge, awesome. Otherwise, this number is perfectly fine. Okay, it looks like there's two more examples here. So the exact area of a triangle with sides 6, 9, and 13. So very similar to the last example. So certainly feel free to pause the video, and if you want to solve it and check your answer, great. Otherwise, just follow along with me. So I've got my 3 sides, 6, 9, and 13. So if I add those up, that's 19 plus 9 is 28 divided by 2. So my semi-perimeter is 14. And again, I got that because it's 13 plus 6 plus 9, all divided by 2. Semi-perimeter, half of the perimeter. So that would be 28 divided by 2 is 14. And then remember, the formula is equal to the semi-perimeter times the semi-perimeter minus each of the side lengths. Okay, so area is equal to semi-perimeter 14 times 14 minus 13 times 14 minus 9, 14 minus 6. And so then I get 14 basically times 40. So there is a perfect square. This 40 here could be 4 times 10, which is a 2 to come out front. And there's 10 left over. And so it looks like it's 2 root 140. And I think there's another perfect square. Oh, no, there's not. Oh, yeah, sure, there's divided by 4. Done. Wow, my brain is in not teaching mode. So it's 4 times 35. So that becomes another 2. So it looks like it's 4 square root of 35. And so if you have that, great. Otherwise, you could have the decimal approximation for square root of 35, which is about 23.664. Okay, so there's that one. Very nice. And again, if I made a mistake, let me know in the comments, certainly. Okay, and the last one says find the area of this triangle, then find the value of C. That's exciting. Well, area of the triangle we know is 1/2 6 times 8 times times sine of 30. So area is 1/2 AB sine of theta. So area is equal to 1/2 8 times 6 times the sine of 30 degrees. Well, that's actually really nice because 30 degrees, the sine of 30 degrees is 1/2. So I can actually do this one without a calculator. 1/2 times 48 times 1/2, assuming I don't make mistakes. So I get 1/4 of 48, which is equal to 12. Now, how to find side C? That you're sitting again in a SAS case. So for area, we were able to use that formula. Remember, for an SAS case, that's law of cosines. And so for law of cosines, actually, I don't know if we've seen law of cosines just yet. So you might need to wait to see the law of cosines video for this particular problem. I can't remember the order, so I'm sorry, I'm kind of rambling. Okay, so law of cosines, c squared is equal to 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of 30 degrees. And again, I know cosine of 30 degrees, but since I'm going to have to square root c anyway, I'm just going to go ahead and throw this into my calculator. So 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of 30 degrees. And don't forget, take your square root. So then I get so C is equal to 4.106. Okay. And then our very last problem, and this is